Exercise 10.2, question 5. Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. We have to prove that perpendicular to this point is always passing through the center. So here we are assuming that it is not passing through the center, but in the end we will be showing that x and o coincides with each other. So it means perpendicular always pass through the center. Like we know only one way to reach some destination, but we are trying other ways also, but in the end we are going to learn that there is only one way to reach that destination. So here we are trying the other way also. So we are assuming that the perpendicular is passing through the point x. So let perpendicular is passing through the point x. Now if it is passing through the point x, it means xpb is the perpendicular. xpb is equal to 90 degrees. But we also know that radius and tangents are perpendicular to each other because OP is the radius. So we will get OPB as 90 degree. Here you have to state that theorem 10.1, which says that radius and tangents are perpendicular to each other, or tangent is perpendicular to the radius through center. So now as their right hand sides are equal, so their left hand side will also be equal. So XPB will be equal to OPB. So if XPB and OPB are equal, this is possible only if, suppose this is XPB, right? Now XPB is equal to OPB only if these both coincides, right? Then only it will be 90 degree. So what we have learned from this, that the only point from which perpendicular is drawn, or the line which is perpendicular to this point, should always pass through the center. So we will write perpendicular will always pass through the center. Perpendicular will always pass through the center. Will always passes through the center. Now question 6. The length of a tangent from a point A at distance of 5 centimeter from the center of the circle is 4 centimeter. So length of the tangent is 4 centimeter and distance from the center is 5 centimeter. We have to find the radius. So as radius and tangents are perpendicular to each other, so this angle must be 90 degrees, and if it is 90 degree, then it is a right angle triangle, and we can apply Pythagoras theorem here. So in triangle AOB, if we will be applying Pythagoras theorem, we will get OA square is equal to AB square plus OB square. Now OA is 5 and AB is 4. So it is 25 minus 16, 9. So OB is 3 centimeter. So radius of the circle will be 3 centimeter. Question 7. Two concentric circles are of radii 5 centimeter and 3 centimeter. Find the length of the chord of the larger circle. Now this is the chord of the larger circle. We have to find its length, and they have also given that which touches the smaller circle. So this chord is touching this smaller circle also. So the radius of the smaller circle, the red circle, is 3 and the radius of the green circle is 5. We will be considering this triangle OMQ to find MQ, and we know that perpendicular to the chord, as it is a perpendicular. Why it is perpendicular? Because this is the tangent to this smaller circle and this is the radius. Radius and tangents are perpendicular to each other. So this is perpendicular. Also perpendicular to a chord from the center bisects the chord. We have already learnt this, that perpendicular from the center always bisect the chord. Or there is one way also, if I will joining this, I can prove that these two triangles are congruent. If they are congruent, then this will be equal to this by CPCT. but that will be little lengthier. So we will be doing with this that perpendicular to the chord always bisect the chord. So here in triangle OMQ, we will have OQ square is equal to OM square plus MQ square. Now what will be OQ? OQ is the radius of the larger circle, which is 5. OM is the radius of the smaller circle, which is 3. So this is 25, this is 9. 25 minus 9 is 16. So what we will get MQ as? MQ will be 4 centimeter. So if MQ is 4 centimeter, PQ will be twice of MQ. Twice of MQ, which is equal to 4 into 2, 8 centimeter. The reason we will be writing for this as that the perpendicular bisect the chord, perpendicular from the center bisect the chord.